Hello, welcome back. Today we're going to be talking about writing equations from application or word problems, and that is our objective for today. If you take a look at the title right here in parentheses, you'll notice that the equations we're going to be looking at today will fall in two categories. They'll either be slope-intercept or standard form. Please try to work through the following problem on your own and press play when you're ready to see the answer. If the way that you work it out is different from mine, but you still end up with the right answer, that's completely okay. However, if you like the way that I think and the way that I work the problem better, please feel free to change the way that you work the problems in the future. So when I'm working out a problem, especially a word problem or an application problem, the first thing I do is I read through the problem and make sure I understand what it's saying and what it's asking, because I can't really answer any questions about the problem until I really understand, again, what the problem's saying and what it's asking. So, you've saved $50 from allowances by the beginning of summer. During the summer, you do not get an allowance because you're expected to earn your extra money. So you decide to mow lawns at $30 per lawn. Write an equation for the total amount of money you have earned after mowing the lawns, assuming you don't spend any money. So we look at the situation, might read through it a second time to make sure I really understand, and start picking out some information that I think is important, at least initially. I noticed that I've saved $50 from allowances by the beginning of summer. During the summer, don't get allowance, expected to earn my extra money, so you decide to mow lawns at $30 per lawn. And what we're asked to do with this is we're asked to write an equation for the total amount of money you have after mowing the lawns. So we're going to be earning some money, or rather you are going to be earning some money after mowing some lawns, and we assume we don't spend the money. So our total money will be fixed. It won't be going down, it'll only be going up because we're earning $30 per lawn. Well, when I look at this problem, I might approach it a couple different ways. One way might be to go ahead and write out in a sentence the total. Since I know I need an equation having a total, I'm going to write out a sentence talking about the total amount of money. So the total money is, and I'll read back to the problem, the amount of money you have would come from the allowances and from the lawns. So it is $50. And that was a one-time deal. That didn't change. So that's fixed. I'm not going to multiply that to anything. What I am going to do is I know I have $50, and I'm going to add to that $30 per lawn. Now, what we don't know is the number of lawns that were mowed. So what I'm going to say is $30 per lawn, but there could be any number of lawns, so I'm going to go $30 per lawn times the number of lawns. So what I have here is I have a sentence that describes the amount of money we have. The money we have, or you have, is $50 plus or and $30 per lawn times the number of lawns. Now the reason I have to multiply $30 per lawn times the number of lawns is because you get $30 for every single lawn. So let's give some of these variables. Total money. Let's call total money T. And $50, that's a fixed amount. And would mean plus $30 per lawn. So we know it's going to be 30 per lawn times the number of lawns. So I'm going to go times the number of lawns. I'm going to say that's L. The word is means that, well, the total money is equal to. So $50 plus $30 per lawn. So my total is equal to the $50 plus the $30 per lawn times the number of lawns. And I've got an equation. Again, if you thought about it differently, that's completely okay, so long as you ended up with the same equation. You might have got the total equals 30 times the number of lawns plus 50. It means the same thing. Here's another problem. I should go ahead and try this problem again on your own. Try to think through it. It's going to be different than the previous one in its nature and the way you set it up. But what I ask is just go and try it out on your own, pause, and when you're ready to see the way that I would think through it, please press play. Now, I know I've already said this, but when I work through a problem, the first thing I'm going to do is read it. Make sure I understand what it's saying and what it's asking, and then I'll go through and see if I can't pick out some important information, or just information, period. So we're planning a banquet, and we have to order some tables for your 120 guests. You have two choices of table sizes. Large tables can sit 6 people, and small tables can sit 4 people. Write an equation that shows the possible number of small and large tables you can use. So go back, look through it. We're planning a banquet. We have to order some tables, and we have 120 guests. So I've got a number here that may or may not be important. I'm going to go ahead and underline it to keep that in mind. We have two choices of table sizes, so 2 choices. And large tables can sit 6 people, so we've got 6 people for large tables. And let me go and do those in different colors just to make sure we keep everything separated. So large tables, again, were 6 people, and small tables can sit 4 people. Write an equation that shows the possible number of small and large tables you can use. Now, what's not told to us in this situation, let me erase that, is that we're not told use for what. So we kind of have to assume in this situation that we are trying to use the tables to seat 120 guests. So 120 is going to be our total. And again, in this situation, I might go ahead and write out it in words and then create the words into an equation. So I look at it, I've got 120 guests in total, and I've got 2 kinds of tables. So I know I need 120 seats. So I know that my 120 seats, 120 guests have to have some place to sit, is going to be equal to some combination of small tables and large tables. But I know that the large tables can sit 6 people. So I'm going to go 6 people times the number of large tables, because each large table seats 6 people. And I might add to that, or rather would add to that, 4 people for small tables. So I'm going to say add 4 people times the number of small tables, because I have a combination of large tables and small tables. All together has to equal the 120 guests for the banquet. So what I'm going to do at this point is turn these words into just numbers and letters. So I'm going to say 120 is equal to 6 people times the number of large tables. I'm just going to say 6L, because the number of large tables, I'm going to call that L, plus 4 people times the number of small tables, I'm going to go 4S, because each small table seats 4 people. I'm going to let the number of small tables be the letter S. And I've written an equation that gives me my total number of people, 120 guests, and my 120 guests sit at large tables, sitting 6 people each, and small tables sitting 4 people each. Here's another one for you to try on your own. Go ahead and press pause. Press play when you're ready to see the way that I would work through it. For this problem, I know that you're given a $100 online music gift store gift card. New albums cost $10 and older albums cost $8. Write an equation that shows all the combination of newer and older albums you can buy with your $100. So kind of similar to the previous problem, we have $100, and our $100 is going to be equal to some combination of the $10 for new albums and $8 for older albums. So the $100 has to be equal to $10 times the number of new albums, the number of new albums, plus $8 times the number of old albums. Now the reason for that again is we have $100 to spend in total, and our total amount of money that we can spend, we're assuming we're probably going to spend all of it, is equal to the number of new albums that we bought times $10 because they cost $10 a piece, and the number of older albums we bought times $8 because they cost $8 a piece. Now all I have to do is choose some variables to represent the new albums and the large albums. So I'm going to say the newer albums I'm going to call N, so 10N, plus I'm going to call the older albums not O, because O often looks like 0. I'm going to say the old albums are G for oldies but goodies. So there you go. You've got $100 is equal to $10 times the number of new albums plus $8 times the number of old albums. Let's take a look at one more problem. Go ahead and press pause, and when you're ready to see the answer, please press play. So we read through the problem. You decide to build a fence around your backyard. Materials cost $3,000, and you're going to hire a helper for $10 per hour. Write an equation for the total cost of building the fence. So we read through it, make sure we identify the important information, or just the information we think we're going to use. We know that materials cost $3,000. We're going to hire a helper for $10 per hour, and we need to write an equation for the total cost of building the fence. Now, we know we're going to be talking about a total, so I'm going to say the total cost is, and our total cost is made up of some materials and the price of hiring the helper. So the total cost is $3,000. And that's just materials, so I need to add to that $3,000 my helper's fee, so $10 per hour but that helper's charging $10 per hour for every single hour, so I need to go $10 per hour times the number of hours the helper works. Now, we could write that out, the number of hours the helper works, or just go ahead and know that that's what that was. So, total cost. I'm going to call total cost T is, we can say is equal to the $3,000 plus the $10 per hour times the number of hours. So I'm just going to go 10H, and H is going to stand for the number of hours. And there we go, we've written an equation for the total cost of building the fence.